This is section 3.3 to 3.5, the review. Calculators still are not allowed, and this is number 2. All 3 of these are requesting that we find the equation of a tangent line at a specific point. So for all 3 of these, we will need a point and a slope, which is a synonym for the derivative evaluated at the point. And if we look at what we're given here, we have only the x-coordinate. So if we do part A, because we know the x-coordinate is pi over 4, we can plug pi over 4 into the function to figure out what the y-coordinate is. Pi over 4 times 4 is a pi, and the sign of pi is 0. So my point will be pi over 4, comma 0. The slope will be the derivative of f evaluated at the point. Remember, we cannot have slopes of lines involving x's. They must be evaluated at the point of tangency. So in order to compute this, I need to first find the slope, or the derivative, and it will involve the chain rule. The first thing I hit is the sign. Derivatives of sines are cosines with the inside unchanged, times the derivative of the inside, which is 4. So if I want to evaluate this at pi over 4, that will be the cosine of pi times a 4, which, if you remember from your unit circle, is negative 1 times 4. Now that we have a point and we have a slope, we can write the equation of the line, which is y equals the slope times x minus the x-coordinate plus the y-coordinate. If we look at part B, again, it will work the same way. We're writing the equation of a line, so we need a point and we need a slope. The point has an x-coordinate of pi over 4. If I plug pi over 4 into the function to get the y-coordinate, I will have the tangent of pi over 4, which is 1. The slope will be the derivative of this function evaluated at the point of tangency. So that requires that I find the derivative of tangent, which is secant squared of x. So plugging in pi over 4, I'll have this secant squared of pi over 4. Now chances are, if you're anything like I am, you have a good handle on sine and cosine because of the unit circle, but the secants and cosecants and cotangents, those are a little more tricky. So to figure out what the secant squared of pi over 4 is, since we do not have a calculator, we need to recall that this is the same as 1 over the cosine of pi over 4 squared. So the cosine of pi over 4, if you recall from your unit circle, pi over 4 is right here, and the cosine is the x-coordinate. Well, that's a root 2 over a 2. So if I take that root 2 over 2 and I square it, I will have a 1 over a 2 over 4. Dividing by 2 over 4 is the same as multiplying by its reciprocal, so I will get a 4 over a 2, which is the same as 2. Now I've got my point and I've got my slope, so I can write the equation of my line, which will be y equals 2 times x minus pi over 4 plus 1. Last one, C. Again, we need a point whose x-coordinate is pi over 4. We also need the y-coordinate that goes with that point, so I take pi over 4 and I plug it in. Sine of pi over 4, that is going to be the y-coordinate. And I'm dividing by cosine squared, which is the x-coordinate squared. So that's my 2 over 4. So let's recall, dividing by a fraction is the same as multiplying by its reciprocal. So that would give me pi over 4 times a root 2 over 2 times a 4 over 2, which ends up giving me a root 2. So I also need the slope, which is the derivative evaluated at the point of tangency, which requires me to take the derivative of this guy up here. So if I take the derivative, I'm going to do low d high minus high d low. Okay, so the d low is going to be a little tougher because I have to use the chain rule. The derivative of cosine squared will be the power rule first, which is 2 times cosine, times the derivative of cosine, which is negative sine. And that's all over my low squared. So now if I want to plug in pi over 4 for this, which is going to be a little more tricky, I'll scoot down here and have cosine squared of pi over 4, that's my x-coordinate squared, so that's a 2/4. Then I'm going to multiply by cosine, which is a root 2 over 2. Then I'm going to subtract the sine, which is the y-coordinate, times 2 times the cosine, which is again that root 2 over 2, times the opposite of the sine. And that's all over the cosine squared squared. So if I square this once, I get a 2 over 4. And if I square that again, I'm going to get a 4 over a 16, or a 1/4. If I put all this together, we can see that on top I'll have a 2 root 2 over an 8 minus a negative 2 root 2 over an 8, all divided by 1/4. Well, that's the same as, if I reduce here, have a 4 on the bottom, and multiplying by 4 is the same as dividing by this 1/4. So actually all of these 4's are going to disappear, and I'm left with the root 2 plus another root 2. So I get a, oops, I lied, there's another 2 here, so I've actually got 2 plus 2 of those root 2's will give me 3 root 2's. So if I finish up now, I'll get y for my line. Y equals 3 root 2 times x minus pi over 4 plus a root 2.